Welcome to this week's Superhero Simulation. This week we're going to be taking a look at a what-if scenario of Captain America versus Iron Man. More specifically, doing a mechanical event simulation in Autodesk Simulation Mechanical of Captain America throwing his shield and whacking Iron Man right in the head. As always, let me know if you have any questions or if you have an idea for a new superhero simulation for me to run. You can contact me directly at james.herzing@autodesk.com, ping me on Twitter at Mr. Simulation Rocks, or at ADSK Simulation. So as I said, we're going to be looking at Captain America throwing his shield. He does this all the time, and apparently when he hits someone it makes a whank noise, or a bang, or a tch, or a whoop. Well, I guess whoop is his punch, but that's okay. The point is, he throws it all the time. I'm told it's his main weapon. It could be that gun he carries, but no, it's much easier to throw your shield. So what do we know about this shield? You can see modeled up in the top and analyzed at the bottom. Well, it was created by Dr. McClane out of vibranium and another unknown substance to try and replicate adamantine. I think that's the same as adamantium, or what it's made out of, and that's the stuff that Wolverine's claws are covered in, or I guess all of his bones for that matter. So it's pretty hard. It's a hard substance. He throws it all the time, like we've already covered. It's his main weapon. It actually has been dented by Thor, but then he had a change of heart and hammered it out, because Thor's a pretty strong kind of guy. And it also was destroyed by Doctor Doom. I didn't really look into that one too much, but somehow Captain America got a wish and got his shield back. It also bounces around like a yo-yo or a boomerang. He can whack like 7 people in one throw, which is pretty darn impressive. So, anyways, let's jump into the software and take a quick look. We're starting off here in Fusion 360 because both of these models were created in GrabCAD, so good job by somebody for creating these. But what I really wanted to do was position the two of them relative to one another to ensure that the shield was going to whack Iron Man in the head, and also to define a distance that the shield was apart from the head so that we could see it flying and then smacking him in the temple. So with that, we're going to then take this model as an IGES file and dump it straight into Simulation Mechanical. So let's go ahead and choose to open this and define our analysis type as a mechanical event simulation. So this is how we're going to be able to define that part moving throughout time and then hitting Iron Man in the head. We could also take into account nonlinear materials with this, but we're not really going to be too concerned with that right now. So with the file open, we can see that we have 4 parts, 3 making up the head and 1 the shield. So let's start by generating a mesh. We don't really want to view the results, we don't care too much about accuracy right now. But something interesting is that 2 of the parts of Iron Man's head are bricks and 1 is a shell. So let's go ahead and define the material for the 2 solid parts of the helmet. And we'll make that out of A36 steel, click OK. And now since another part is a shell, we have to define a thickness for it, and we're going to claim it to be 5 millimeters thick. So this is a very strong and thin substance. So this substance we're going to call A36 steel as well, because that's what we do here in Simulation Mechanical. And lastly, we need to define the material for the shield. So let's go ahead and make this a little bit stronger. And since it's a mystery material that Dr. McClane put together, let's go ahead and call it a titanium alloy for now. And click OK. So with our materials defined, now we can add our loads and boundary conditions, set up our analysis parameters, and be good to go. So let's start by adding a fixed boundary condition to Iron Man's helmet. If we zoom in there, we can change our selection type to be a polyline select, and we can choose to select vertices. And let's just quickly draw a line around the bottom of the helmet, selecting all of those nodes, and now right-clicking and adding a fixed boundary condition. So 1 click here, fixed, and all of the degrees of freedom on this shell are going to be fixed. So now we're saying that the helmet is kind of like welded onto the rest of the suit. I guess that's a fair assumption. Next, we need to apply our load to the shield. So instead of adding a force or something like that, we're going to claim this to have an initial velocity saying that Captain America has thrown this, and now it's whizzing towards Iron Man's head. Somehow he caught him off guard. So with that initial velocity, you can see that it's going to be moving in the negative z direction towards Iron Man. So we type in, let's say, a minus 2,000. And now let's give it a rotation as well. So let's just pick a point near the center of that shield for it to be rotating around. And this is actually moving so fast in such a short distance that it doesn't really matter. And we'll give it a rotation around the y-axis of 200 RPMs. And click OK. And now we're going to have the shield smack him in the head. But first we have to apply our parameters. So up at the top at the analysis type, right-click and choose Edit Analysis Parameters. And here we're going to define the duration of our analysis to be 0.04 seconds and give it 200 steps. So it's going to divide that 0.04 seconds into 200 smaller chunks. We're also going to define how our load is applied. So we're going to say that between time 0 and time 0.01, our full force is going to start being applied, and then for the remaining 0.03 seconds, it's going to continue to move at the rate of speed that we defined. And now click OK. So with that, we can analyze our model and jump into the results. So here in the results, we see that at time step 0, we have nothing going on. I've looked ahead and figured out that looking at about 170 for our load case gives us a nice view of what's happening. And when we do that, you can see the shield contacts Iron Man right around the temple and gives him a good bang in the head. So unfortunately for him, he's probably going to be knocked out by that very strong shield toss. We can turn that off and get a better look at what's going on here with the helmet. And we can also animate this to take a look and see what it looks like in motion. So here we have a quick animation, and there's a shield hitting him in the head and then bouncing back, and I assume straight back to Captain America's hand, like always. And one more look at that. So let's also take a look at just the helmet, and you can see the stress all around the earpiece. So that's about all we have today. If you have any suggestions on further topics, if there's any questions you have on this analysis setup, or if you'd like to correct me on, I don't know, any of my what I'll call facts about these two superheroes, please feel free to do so. Looking forward to it. Thanks.